Good morning, students. Today we are going to see about the ARM processor. So ARM processor is something that it is an advanced RISC machine. It is a 32-bit reduced instruction set computer based on load store architecture. Let us see in detail. So ARM is something that your advanced RISC machine, and it is founded in 1990s in Cambridge, UK, and it is also known as a RISC processor, and it does not manufacture of a silicon. So it is based on load store architecture. So it is a first RISC processor for commercial use, and that came to market, and it is very low power consumption and cost effective for all embedded system application. These are the ARM office which is located in the worldwide. Next, let us see about why we go for RAM. So it has a low power consumption and fast execution per watt, and it is very inexpensive and variety of core offering and marketing. So in 2050, about 98% of all mobile phones use at least one of ARM designed core has on their motherboards, according to the research from the analyst of Linux groups. Okay, so the processor originated in England. Okay, and it is based on a von Neumann architecture, that is a load store architecture. That is, it has a 32-bit data bus for both instruction and data, also for load and store info instruction accessing memory. And the license of ARM core design to the semiconductor partners who is fabricated and sell their customers. And ARM does not have a fabricated silicon itself. Okay, so let us see the overview of ARM. So the architecture for the digital world, and it is a physical hardware design with intellectual property of a company, and the license its cores out, and other companies make the processor based on its cores. And ARM also provides a tool chain and debugging tool for its cores. And these are the companies which has licensing of ARM IPs. And this is a basic architecture of ARM processor. So ARM architecture for diverse embedded processing needs. So that is Cortex A, that is a high performance processor which is optimized for rich operating system. Next one is your Cortex R, that is a fast response processor which optimized for high performance hard real time application. Next one is the Cortex M, it is the smallest and low power system optimized for discrete processing and microcontroller. Next, this is the various ARM architecture. The initial stage one is ARM 7, next is ARM 9, ARM 11. Based on the Cortex, based on the application, the various ARM process has been used. So before going to in detail of Cortex, so let us see the basic things that is related to the ARM architecture. So ARM is something that a 32-bit architecture. It means byte means 8-bit and half word means 16-bit. I hope you all know about word means 32 bits. So most of ARM implemented in two instruction set, that is 32-bit instruction set or 16-bit instruction set. So the memories are addressed as a 32-bit address, and the data types can be either 8 bytes or 16-bit half words or 32 bits. And it is the first commercialized processor which has maximum of 25,000 transistors. So this is a basic block diagram of embedded ARM Cortex processor. So this is Cortex M0, that is, it has a ultra low gate count less than 12k gates, an ultra power of 3 microwatts per megahertz, and 32-bit processor based on ARM v6 architecture. So next is your Cortex M1. So this is the first ARM processor designed specifically for implementation of FPGAs, support all major vendors FPGA, easily migration path of FPGA to ASIC based on ARM v6M architecture. Next is your Cortex M3, the mainstream ARM processor for microcontroller application. Next one is your high performance and energy efficiency, an easy migration path from FPGA to ASIC, advanced three-stage pipelining, and based on ARM v7m architecture. So the next one is your Cortex M4. It is an embedded process for DSP, and it supports all four floating point operation. It has a special floating point unit. So this is based on ARM7 architecture. This is a detailed block of ARM7 architecture. We'll see detail about the ARM architecture in upcoming classes. Okay, thank you. If you have any clarification, feel free to contact me.